Today we are going to discuss a question based on theorem number 1.1 Euclid's division lemma. We are going to see how we can solve this question easily by applying the lemma, and I'm going to make it very easy for you to solve such type of questions. So let's see. Example 4. A sweet seller has 420 kaju barfis and 130 badam barfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number that can be placed in each stack for this purpose? So there is a sweet seller who has 420 kaju barfis and 130 badam barfis. She wants to stack them in a way such that each stack has the same number. So basically we want each stack to have the same number of barfis and they have to take up the least area of the tray. So what this means is that in every stack we want the maximum number of barfis to be there, right? So that there are minimum number of stacks. We want maximum number of barfis, and so we need to find the number of stacks. So if you want maximum number of barfis, to find this, we are actually going to need to find the HCF of both of these numbers. Yes, we are going to find the highest common factor of both of these numbers. That means we're going to find the highest common number which divides both of these, so that number of barfis can be placed in a single stack. Let's see the solution. To solve this problem systematically, we find HCF of 420 and 130. As I explained earlier, this is what the question is trying to say. This question is a little big and it is a little different, you might say, but it is very easy and it is not a very difficult question for you to solve. So, since 420 is greater than 130, we apply the division lemma to 420 and 130. So the first condition in Euclid's division lemma is that the number which is greater, we are going to consider that number as the dividend. So on applying the lemma, we get 420 is equal to 130 into 3 plus 30. Now we need to keep going until we get the remainder, that is this part, as 0. So here the remainder is not 0. So we do this, we apply the lemma again, this time with 130 as the dividend and 30 as the divisor. So 130 is equal to 30 into 4 plus 10. Again the remainder is not 0. So we are going to apply the lemma with 30 as the dividend and 10 as the divisor. 30 is equal to 10 into 3 plus 0. So now you can see that we have reached 0 in the remainder, and this implies that we have to stop now. So since the divisor at this stage is 10, the HCF of 420 and 130 is 10. Now, as mentioned earlier in Euclid's division lemma, whenever at whatever stage we get the remainder as 0, the divisor at that stage, the divisor, this one, would be the HCF. So here the divisor is 10 and hence the HCF is 420 and 130. Therefore, the sweet seller can make stacks of 10 for both kinds of barfis. So basically the sweet seller can place a maximum of 10 barfis in one stack, then 10 barfis in another stack. This is what we need. So this was the question, and I hope that you found this question more clarified and more easy to solve. And we are going to look at some bonus tips and tricks. Always use pen and paper to solve such questions. Yes, this is a very important and an old trick, and I always say this, that you need to use pen and paper. Don't try to solve these questions mentally. It might increase the chances of getting a wrong answer. Read the question carefully. Read it multiple times as I mentioned earlier for clarity, and try to do it yourself. Don't skip any step. So this time I hope I made it clear, and I hope that this would be very easy for you to solve, and I hope that you try this question again yourself. Thank you for watching.